Hello class. In this video we're going to learn how to apply the properties of transversals. So first off, what is transversal? Well, here it's basically a line that cuts two other lines in different points. Now, when I say different points, that's important because that's saying that this can't happen. This red line here would not be a transversal if these three lines are concurrent. Now, usually you see a transversal when lines are parallel, but they don't have to be. So in order to show that lines are parallel, we put these little chevrons on them, those little arrows. That means that those two lines are parallel. So here's transversal. And before we get into the different angle pair relationships, let's go about defining them. And so here is the textbook definition of an alternate interior angles. So if we look at, if you read the definition and look at our PQ, that's this angle over here, and PQS, those are alternate interior. That's a wordy definition. Here's a shorter one that means the same thing, but it's not as rigorous. Basically, they are on touch different lines, right? This one touches L, this one touches M. They're on opposite sides of the transversal, and they're on the inside of the two parallel lines. Corresponding angles. So according to this definition, well, we look at X and Y, those are alternate interior. And then Y's vertical angle would be Z, so Z and X are corresponding. Now, a less formal definition is they have the same spot, right? So if I take angle X over here, let me make that transparent, and if I move angle X, I move the vertex down to the other vertex, X and Z would lay right on top of each other. That's what I mean by corresponding. Alternate exterior, they're opposite sides of transversal, touch different lines, but now they're on the outside of the two lines. And consecutive or same side interior angles are angles on the inside that are on the same side of the transversal. So now that we know all those, let's look at what happens when we have parallel lines. When the lines are parallel, the corresponding angles are equal in measure. They're congruent. So which ones are corresponding here? You have A and E, B and F, D and H, and C and G. And alternate interior angles are equal in measure. So which ones are alternate interior? You have C and F, and D and E. We also know that alternate exterior angles have the same angle measurements. So we have A and H and B and G. Now be careful. The last pairs are not congruent. They are supplementary. Same side interior angles. So same side interior would be D and F and C and E. Now they could have the same measure, and when does that happen? That only happens exactly when they are both 90 degrees. So here are a few examples. I want you to look at them and think about which angle pair we have, and then what the measurement of the missing angle must be. So in number 1, we have corresponding angles. So they're both 48s. In B, we have same side interior, so they are supplementary. So B is 180 minus 48, 132. Alternate interior angles, that must be 48. And 4, those are alternate exterior angles, so it must also be 48. Here's a little algebra with the same ideas. So see if you can figure out what X and Y are, and then I'll show you the way I solved it. Now I'll show you the answers, and even if you have the same answer as me, but you did it a different way, that's okay. You most likely did it in a correct fashion. Just because you don't do it my way doesn't mean it's wrong. So the way I looked at it was I said, hey, 5x plus 15 must be the same as 110 degrees because those are corresponding angles. So subtract 15 from both sides, divide by 5, and you get 19. And I said for y, I said these two are supplementary, right? They're a linear pair. So they must add up to 180. And so y is 98. Now, sometimes you're going to have to draw something called an auxiliary line. Right? Auxiliary means helper. And this line is going to help us figure out what angle W is. Angle W is in here. So this whole thing is W. But we can't directly use our angle properties with it because it consists of two angles, E and F, that we can add together using the angle addition postulate to find it. So angle E, when we draw that auxiliary line in there, this dashed line, that's going to be 41 degrees because those are alternate interior. And F is going to be 35, alternate interior as well. And so W, when we put those together, will be 76. So maybe you want to think of it as you start off with no helper line there, no auxiliary line. And then you realize, hey, that would be a useful way to find that angle by drawing it in there. So that's the idea here. So in these examples, you're going to have to draw some auxiliary lines in to find the missing variables. So once again, for each one, take a moment to pause it, try it, and I'll show you my solution. So here, I drew a few auxiliary lines because you only know that this top one and the bottom one are parallel. And so I drew one there. So I drew two auxiliary lines. And I used the properties of same side interior angles to solve this. And so if this is 110 degrees, and this one must be, oops, that's all I want to do. All right, this one must be 70, so they are, because they're supplementary. And now you know that whole angle here, this whole thing is 80 degrees. So if the top piece is 70, the bottom piece must be 10. There we go. And excuse me for a sec. All right, there we go. Okay, so this is 10 degrees, same side interior, so these two must be supplementary. If that's 10, this one must be 170. And we know that this whole angle around here must be 310. So subtracting 310 and 170 gives us 140. And so 140 in A. Let's see, A's measure is going to be supplementary with 140 degrees, so A must be 40. But a lot of ways to do that one. That was just the way that popped out to me as being one way to solve it. Let's see, B and C here. Let's see how I drew my auxiliary lines. Maybe you did it the same way. So I thought finding C was actually a little bit easier here, a little more straightforward. So when I drew these auxiliary lines, I saw that 46 degrees, that angle here, is going to be alternate interior with angle C. So C must also be 46 degrees. And then I looked over at this line, one in red, and that forms a linear pair with the 94. And so that must be 86. 180 minus 94 is 86. And now if I put my helper line back in there, one I just erased, put it back in there now, then this angle over here must be 48. A few ways to reason that through. I said 180 minus 46 minus 86 is 48. Lots of ways to think of it. So B and this angle 48 are alternate interior. So that's 48 degrees. So I hope that you're reasoning through the different angle pair relationships that you're using as you go through the problems. So here we have two pairs of parallel lines. Here's how I drew mine, my auxiliary lines. Right, you can also extend them like that. Right, lines go on forever. So 122 is alternate interior with D plus this angle right here that measures whatever D measures plus 72 degrees. So 122 minus 72 gives us 50. And now if we look at the blue lines, we see that D and E are alternate interior angles, so E is also 50 degrees. Okay, and last but not least, we have this one, a little algebra in there too. So here's how I drew my auxiliary lines. See if you drew them the same way. And oh, spoiler, these two are what types of angles? Same side interior. So they are supplementary. So you know they add up to 180 degrees. So we can solve for x to get 25. And now you got to think of, well, which one of these two is f congruent? The way I reasoned it through was we have f is alternate exterior with this angle over here, and that's alternate interior with 3x plus 7. So f is going to have the same measurement as 3x plus 7, so plug in 25 for x, and you get 82 degrees. So in this lesson, we learned how to apply the different properties of transversals, especially when we have pairs of parallel lines. Thanks for watching this video.